Using our definition of limit, we arrived at a couple of simple known limits, namely the limit as x goes to some finite value for a constant, and the limit as x goes to some finite value for x itself. We came up with these limits. I suggested, but we certainly didn't do anything approaching a rigorous proof, that for most functions, the limit as x approaches c of the function is simply the value at the point. But remember, there are situations where the limit has absolutely nothing to do with the value at the point. And it's really to that these next couple of videos are focused. So let's talk about how we find limits of things that are not basic known limits. Again, we have the identical progression that we used in calculating limits as x goes to infinity. First, is it a known limit? Second, can I graph it? Third, we have limit laws. Fourth, algebraic simplification, and so on. Now, the 5 limit laws are, as I said, almost identical to the ones that we had as x approaches infinity. The only difference is a technical one, and it's not something that we're going to cover. So let's take a look at a couple of examples just to make sure we understand how the limit laws would work. So again, you look at this function that's given, 3x squared plus 2, and you have to conclude that no, that is not one of the known limits that I've looked at, but you determine that you can simply use the product limit law. I'm sorry, not the product. First, you can use the sum limit law to turn this into the limit as x approaches. Here, I didn't state what it is that x is approaching. Let's say as x approaches 2. Limit as x approaches 2 of 3x squared plus the separate limit as x approaches 2 of 2. This is a known limit. That's just 2. Here, what can I now use? I'll use the product limit law. In fact, I'll use it twice. So this is the limit as x approaches 2 of the 3 function times the limit as x approaches 2 of the x function times the limit as x approaches 2 again of the x function plus 2. These are each known limits. This is 3. This is 2. This is 2. 3 times 2 is 6 times 2 is 12 plus 2 is 14. Pretty straightforward way to break it down. Let's try this one as well, just to emphasize the point. This we could break down first using the quotient limit law. Limit as x approaches 3 of the quantity e to the x plus sine x over a separate limit as x approaches 3 of 2 ln x. That we will further break down. We'll use the sum limit law here. We'll use the product limit law here. And so we get ultimately limit as x approaches 3 of e to the x plus limit x approaches 3 of sine x all over the limit. I won't write x approaches 3 just because I ran out of space, of 2 multiplied by that same limit as x approaches 3 of ln x. All of these are known limits, and so in the end we just have e to the 3 plus sine 3 over 2 ln 3. At this point, it's fair for you to say, why is it that we're having to do this whole rigmarole with limit laws? It looks to me like you just plug in the value for x into any function and out pops the limit. There's nothing fancy going on. Well, that's true for most situations. But the situation that matters is the one where that starts to break down. And so it's that I want to now illustrate. Not sure how we got this stray markup here. Let's see if we can't get rid of that. Okay, so we've got a limit as x approaches 4 of a function that we've seen previously, x squared minus 1 over x minus 1. That's going to be, we'll try the quotient limit law first. Limit as x approaches 4 of x squared minus 1 all over the limit as x approaches 4 of x minus 1. And we'll break that into a product times a product and a difference. So we get limit x, I'm leaving out the as x approaches 4, limit x minus limit 1 all over limit x minus limit 1. This is a known limit, it's 1. This is a known limit, it's 1. This is a known limit, it is 4. This is a known limit, it's 4. This is a known limit, it's 4. We get 16 minus 1 is 15 all over 3. So what's the big deal? Well, let's try to do that same thing here. We'd write out the same language. We would get down to the point where So what's the big deal? Let's just use the same quotient limit law, product, difference, limit laws, and let's just cut to the chase. We would get 1 times 1 minus 1 all over 1 minus 1. And that is 0 over 0. Dun dun dun. Okay, so that's where the problem occurs. We've used the limit laws. It's not that we haven't broken some rule, not that we haven't failed to obey the rules. It's simply that we end up with an indeterminate form. And when you reach an indeterminate form, it's telling you that you haven't done enough. And it's for these cases that we have to use algebraic simplification before applying the limit laws.